Good morning and welcome to today's webinar. My name is Keira Proctor and I'm the Managing Director of the A. Proctor Group, and today's presentation is the second of 2022. We've been running our series of webinars since April of 2020, and if you've missed any of them or are joining us today for the first time, you can go back and catch up with the full series here on our YouTube channel. You can also visit our Learning Hub at www.proctorgroup.com, where you can order product samples or book in with our team for follow-up meetings. Today's webinar is the first of several this year, where we'll be looking at a specific project, encompassing the products, processes and design considerations involved, and this one is slightly unusual in that it's also my own house. So we'll start by looking at the background to the project and some of the planning conditions, then look at the Fabric First design philosophy and how the principles of passive house design were applied in practice. We'll then look at some of the more unique design features and discuss the implications of incorporating them. We'll finish up with our regular Q&A session, today featuring special guest and Associate Architect David McFarlane of Allan Corfield Architects. My home, Tickety Boo, is a bespoke 4-bedroom, 475 square metre eco-home near the village of Insture in Perthshire. Although not Passive House certified, the design is based on passive principles and utilises structural insulated panels, low air leakage rates and heat recovery to deliver outstanding energy performance. The 2-element single and 2-storey design also uses local windstone, timber, frameless glazing and a strong focus on detail and craftsmanship to complement its surroundings. The plot, directly adjacent to historic and listed walled garden, posed planning challenges, with the initial application rejected. The revised and successful proposal by AC Architects addressed these issues by creating a direct dialogue with the existing historic walls. Although, being listed, these existing walls could not be incorporated into the design, the relationship between the redesigned structure and the surroundings was welcomed by Perth and Kinross Planning, as well as Historic Environment Scotland, leading to the project being granted approval in late 2016. Beginning on site in August 2017, the project was completed in June 2018, with the combination of off-site panel manufacturing and the high-performance Wraptite vapor-permeable membrane, enabling a simple and fast build process. The SIP system was delivered to site ready to be erected and jointed immediately, and once wrapped in the airtight and vapor-permeable membrane, the shell became wind and watertight, allowing internal works to commence immediately. The kit was erected in November, and despite there being a delay with the windows and doors not being delivered until January 2018, the use of Wraptite around the structural kit and over all window and door openings kept the building entirely wind and watertight over a relatively bad winter. This use of Wraptite to keep the interior warm and dry allowed fitting out to be undertaken in parallel with the final exterior finishing. With the bulk of the build process taking place over the winter months, this temporary weather protection was particularly advantageous. The design is based around the Fabric First concept and uses passive house principles to reduce energy consumption as far as possible. The Fabric First approach is based around ensuring the building elements are well insulated, airtight and as efficient as possible, rather than relying on mechanical and electrical systems or renewable power. The 5 core principles of this passive design are thermal insulation, thermal bridge-free design, airtightness, ventilation with heat recovery, and high-performance glazing. Designing according to these principles is to minimise the energy inputs required to maintain a comfortable indoor temperature. Ideally, the space heating and cooling energy requirements can be reduced to the point that passive sources source as solar gain and heat from the building occupants are sufficient for most of the time. The Passive House Institute provides software known as the Passive House Planning Package, or PHPP, to calculate these energy loads, and provides prescriptive guidance and details along with product certification. Passive House guidance itself is a fully open source and is freely available, so there's no need for official approval to undertake a Passive House project, unless you want the project to be certified and accredited. In this case, PHPP was used to develop and assess the design, but the final project is not Passive House certified. This approach combines the best practice efficiency of passive homes with unlimited design flexibility in terms of material and product specification. For self-build projects, this flexibility allows greater freedom to adjust designs and specification if project scope or priorities change during the build. Whilst that wasn't the case here, it's worth bearing in mind if having the Passive House Approved sticker is not considered critical. Tickety Boo is A-rated for both energy efficiency and environmental impact in terms of CO2, achieving a gold standard under 7 section of the Scottish Technical Standards. Design CO2 emissions are just 6 kilograms of carbon dioxide compared to the building standards target emission rate of 17 per square metre per year. So let's take a look at the 5 principles in a bit more detail and how they were implemented. Thermal insulation is what limits the loss of heat from the building envelope and is the cornerstone of the fabric-first approach to building design. This approach seeks to maximise the performance of the basic components of the building, rather than relying on mechanical or electrical systems. There are 3 main metrics used to measure insulation performance: thermal conductivity or lambda value, thermal resistance or R value, and thermal transmittance or U value. The first of these, thermal conductivity, is a property of the particular material, regardless of its thickness. So, in the case of the panels used at Tickety Boo, the core of each panel is a rigid polyurethane foam with a thermal conductivity of 0.024 watts per metre Kelvin. Thermal conductivity is a good way to compare the relative performance of different materials, but in design terms, we need to also account for how much material is used. For this, we use the thermal resistance, or R value. The panels used here are 172 mm thick, which comprises 2 skins of 50 mm OSB with 142 mm of the PU foam between them. To derive the thermal resistance, we take the thickness in metres, 0.142, and divide by the thermal conductivity of 0.024, giving us an R value of 5.91 meters squared Kelvin per watt. The R value still doesn't tell us the whole story though, as this is the insulation in isolation. The next step is to calculate the thermal transmittance or U value, which is the rate at which heat flows through the entire wall assembly. In this case, the wall also uses the reflected thermal insulating vapour control layer with the service void and plasterboard internally. Externally, our Wraptite vapour permeable air barrier was applied across the whole kit and finished in either stone, timber or render. To determine the U value of the whole wall element, we take the sum of thermal resistances for each layer of the wall and take the inverse. This is the U value, which is measured using watts per metre squared Kelvin, and the lower the value, the better. The building regulations in Scotland recommend U values of 0.11 for roofs, 1.4 for windows, 0.17 for walls, and 0.15 for floors, which are the values used in the notional building used in calculations to determine compliance with building regulations. Backstop, or worst permissible values, are higher at 0.15, 1.6, 0.22 and 0.18 respectively. Tickety Boo's U values are 0.12 for the roof, 1 for the windows, 0.14 for the walls and 0.12 for the floor. Being below the notional values, these U values make a net gain to the energy performance, which could allow trade-offs to be made in other areas like glazing if necessary. The second principle of Passive House is the thermal bridge-free design. A thermal bridge occurs either where a material of higher thermal conductivity intersects a less conductive material, or where building elements join, such as at floor zones or corners. Thermal bridges have 2 principal negative effects. Firstly, they increase the overall heat loss by providing an easier pathway for heat to escape, and secondly, they create cold spots internally. Condensation and mould growth can occur in these areas, which has a detrimental effect on the indoor environment. To see how much difference this makes to the U value, let's take a look at the 0.14 of the SIP panel wall. The system uses a much lower quantity of structural timber compared to a conventional timber frame wall. So when we calculate the U value for a SIP wall, convention is to use a bridging fraction of just 4%. In a conventional timber frame, this rises to 15%, so a much greater correction is needed and our U value of 0.14 becomes 0.17 instead. The second situation thermal bridging can occur is at junctions such as floor zones and corners, and this is accounted for by using an additional value for linear thermal bridging, known as a psi value. In most cases, these are addressed using standard pre-assessed details to limit heat loss, rather than being unique to a project. SIP systems have a further advantage here in that the more standardised nature of such constructions means less deviation from the standard linear bridging details is needed, simplifying compliance considerably. A further benefit of a SIP system at junctions is that the quantity of timber required at these joints is much reduced. At the panel junctions of Tickety-Boo's SIP wall and roof elements, while there is a small area where insulation is reduced, compared to the equivalent in a conventional frame, this is minimal. While it's a simple matter to add additional layers of insulation to a frame to counteract this, avoiding the problem in the first place simplifies things further. This difference is even more apparent when we look at an internal wall junction, where in a SIP wall only fixings penetrate the insulation layer. The timber frame wall, in contrast, needs additional timber to provide a fixing, increasing the thermal bridging at the joint. Whilst each of these areas make a fairly minimal contribution to the overall heat loss rate, taken together they all add up, especially for large and complex projects with complex geometry. A good example of this on this project is the change of level between the kitchen and living area, where there's a substantial step to the ground floor slab. To minimise the cold bridge in this area without increasing the depth of vertical elements, 10mm Space Therm aerogel blanket was applied directly to the internal face of the foundation. This flexible high-performance insulation matting is ideal for use in areas such as this, where even a relatively small R value is sufficient to prevent the formulation of a cold spot internally. This approach is also useful in areas where space may be limited, such as in window reveals or where larger sections of structural steelwork pass through insulation layers. At the A. Proctor Group, we have long recognised the importance of a holistic approach to managing heat, air and moisture in buildings, and achieving good air leakage performance is key to this. By airtightness, we're referring to limiting the uncontrolled movement of air through gaps, cracks and porous material within the heated envelope. This air movement causes not just infiltration of cold air from outside and corresponding exfiltration of heated air, but can also pull and push moisture-laden air into the building fabric. If this moisture-laden air cools down too much, it can condense into liquid water, leading to damp and mold growth. Air infiltration is measured by either pressurizing or depressurizing the building to a level of 50 pascals, and the results are given in cubic meters of air that leak in or out per hour per square meter of floor area. The Scottish Building Standard doesn't set a maximum or backstop air leakage rate, but recommend a maximum value of 10, with 15 being used as the default value for assessment if no specific rate is stated. To calculate the target emissions for the building, a value of 7 is used, so above 10, the energy performance standard becomes incredibly difficult to meet. By far exceeding this requirement, Tickety-Boo's air leakage rate of 0.64 makes it a net gain in terms of building regulations compliance. If energy efficiency was not the primary concern, this net gain could be used to trade off other areas such as thermal insulation or glazing area. Here, however, it plays a critical element in reducing heat loss and corresponding space heating energy use. To visualise these values, buildings with an air leakage rate of 10 metres cubed per square metre per hour will have gaps and cracks equivalent to an area of 1/20 pence piece per square metre of floor area. In contrast, buildings like Tickety-Boo, which meet the more stringent passive house standards, will have gaps equivalent in area to a 5 pence piece every 5 square metres of floor area. There are several factors that contribute to this very low air leakage. Firstly, the structural panels themselves are inherently airtight, with both the foam core and the OSB facings offering very limited pathways for air movement. The panel joints are made using a smaller infill panel with similar properties, and as both of these infills and the main panels themselves are made off-site in factories, the improved dimensional tolerance ensures extremely tight joints can be made reliably. Next, the SIP structure is wrapped in our Wraptite vapor permeable air barrier membrane. This self-adhesive membrane further seals the panel joints and the junctions between the walls and the roof. This facilitates lower air leakage in two ways. Firstly, it provides a robust airtight layer which, being fully adhered to a rigid substrate, is able to resist damage from the weather. The self-adhesive material also makes it far simpler to achieve a high-quality on-site installation, with far less possibility of poorly sealed junctions, reducing the effectiveness of the airtight barrier. Secondly, because it's vapor permeable, it can be positioned anywhere in the construction without affecting the movement of moisture. This means the airtight layer can be located where it's easiest to keep both continuous and avoid penetrations. If, as is traditional, the internal vapour control layer is used as the air barrier, this requires all service runs and penetrations to be designed and installed to minimise puncturing the membrane. Whilst this need not necessarily pose a problem, the nature of sites and trades, particularly in the UK, is such that VCL integrity cannot necessarily be depended on. In, for example, Scandinavian countries, where low air leakage rates have long been standard practice, every plumber and electrician will be used to working carefully around air barriers. However, in the UK it's not uncommon for holes to be cut and drilled and work undertaken with no thought given to any knock-on effect on air movement. Wraptite moves the air barrier to the outside, well clear of most surfaces. This also facilitates straightforward sealing of complex curves and forms, and means features such as floor zones and roof wall junctions can be easily dealt with by simply wrapping the whole building in a single product. The Wraptite is fully BBA certified for use on walls and in warm roofs, so in this case the entire superstructure of the building was wrapped. Once fitted, the building shell is then wind and watertight, so progress can be made on fitting out, and air pressure testing can be undertaken earlier in the build schedule, giving more flexibility on timings, and potentially easier fixes to any problems which do arise. The final point to consider with air leakage is simple attention to detail. Designing, specifying, and scheduling with airtight construction and energy in mind greatly simplifies this process. At Tickety-Boo, this attention to detail even extends to a specialised airtight cat flap, complete with collars for my two Bengals, Thomas and Miles, which allows only them to enter and leave the house at their leisure. Also very good for locking them in or out from our phone app remotely and keeping an eye on them. When unplanned air leakage is reduced to such low levels, a well-planned and executed ventilation system becomes more important. In common with most passive homes, Tickety-Boo uses a mechanical ventilation system with heat recovery to maintain a healthy indoor environment whilst minimising heat loss associated with ventilation. In MVHR systems, heat from extracted airflow is recovered through a heat exchanger and fed back into the building via the incoming supply air. This improves the efficiency of the building by reducing heat wasted by the extract airflow, which in turn reduces the space heating requirements. The system is also fitted with a summer bypass, so fresh air can be brought in unheated when necessary. The MVHR can be turned up or down depending on the time of year and the requirements of the occupants. The gas-fired heating system runs underfloor heating in the downstairs areas. The upstairs rooms, while fitted with conventional radiators, in practice require very little heating due to the overall efficiency of the external fabric envelope. As well as the high-efficiency heating and heat recovery, the house is designed to take advantage of solar gains to provide additional space heating. Glazing performance and orientation are important considerations in any low-energy building, and the windows used here are frameless triple-glazed units, achieving U values below 1, and most of the glazed elements are south-facing. The windows supplied by Lumi are unique in terms of their aesthetics and offer a unique look to the overall project. As part of the initial design of the house, a solar path analysis was conducted to model how sunlight would fall on the building. This data can then be fed into the energy modelling software, and any design tweaks necessary can be made. This allows the position of the glazing and layout of the rooms to be optimised to take advantage of solar gains, with shading elements added to reduce potential overheating. This holistic view of energy use, heat gain, and how the building is used is key to delivering a successful low-energy design. To this end, the accommodation areas are separated from the kitchen living entertaining space, where temperatures would typically be higher. The living area is also more heavily glazed to maximise solar heat gain and natural lighting. Separation functions also help maximise the effectiveness of the zoned heating controls, ensuring space heating is distributed as efficiently as possible. From the outset of the project, a strong focus on high-quality design, finishes and craftsmanship was a principal consideration, as was making a fully accessible home. The central glazed atrium and entrance hallway highlights this, where a handcrafted walnut staircase and matching walnut flooring sit next to a glass-fronted lift. These handcrafted details continue into the entertainment space with LED-lit bespoke cornicing and Georgian detailing contrasting traditional elegance internally with the more modern aesthetic found externally. This approach to detailing continues into the cinema and games rooms, where traditional wall panelling and cornicing contrast with constellation ceiling lighting and modern audio-visual equipment. The upstairs balcony is home to a seating area outside the nursery, with the landing spanning the whole upstairs area, leading to the other bedrooms. The master bedroom suite features a large balcony and sunken ensuite bath with views over the historic walled garden, and the garden to the front is home to a recently added garden office and outdoor kitchen, designed and constructed by Sonder Limited. This building follows similar principles to the main house, with underfloor heating, a structural panel envelope and use of Wraptite, making it a comfortable and energy-efficient multifunctional work and entertainment space. Sonder Limited did such a fantastic job with the design and delivery of the project, it feels like an extension of the house rather than a garden office. So, I come to the end of our quick tour of Tickety Boo, and we'll now move on to our Q&A session. Good morning, everyone. Thank you very much for joining our second webinar of 2022, which just so happens to be about my own home, Tickety Boo, which is where I am broadcasting from today. And I do warn you, the cats are not locked out today, so I'm hoping they won't be too much of a bother. I hope everyone's well and taking care. As you know, we will stay as long as it takes and try our best to answer all of your questions. So please ask them here on your YouTube, email us at webinar@proctorgroup.com or DM us on Twitter @proctorgroup. We already have quite a number via email, so please keep them coming. If you'd like to request a product sample pack containing all the materials discussed in today's webinar, or book a meeting with one of our technical staff, then you can do that now on our webinar page. Personalised CPD certification is also available on the same link, which is www.proctorgroup.com/webinar. You'll be able to now register for our next webinar. So please pop the date in the diary. It is Friday, the 25th of March, and the topic will be Enerfit Fabric First in Retrofit Construction. So we have a fantastic guest, Katrina Jordan, who is the head of retrofit programs at the Construction Scotland Innovation Centre. If you've registered, you will receive a follow-up email with all of these links and a link to the replay. Please circulate it to your colleagues, anyone you think who may be interested in it, and just get them to touch base if they need anything further. It really helps us if you give us a thumbs up on the video, and also please subscribe to our channel. If I just start by introducing the panel, please. Pamela Howitt is our Senior Technical Advisor at the Proctor Group.
Morning, everyone.
Morning, Pam. Sue Menmuir, who I'm sure many of you have also seen before if you've attended our webinars, is our Technical Advisor.
Good morning.
Morning, Sue. Adam Salt is our Regional Sales Manager.
Morning, everyone.
And our special guest, David McFarlane, who's a Senior Associate and Technician of Allan Corfield Architects.
Morning, everyone.
Morning, David. Nice to see you. I'm sure I was the bane of your life for a while. So I'm very thankful that you've joined us today. So thank you very much. So I'm just going to start with the questions straight away because we're already receiving quite a few. So bear with me, they're coming in on different mediums. So as I say, we'll be here as long as it takes to answer all of them. Stuart, I'll start with your question, which I guess I can answer. Just wondering why you didn't go for Passive House certification. For me, Passive House certification is really about, great practice and principles, and specifically around accountability for the designers and contractors that are doing your build. So to be completely honest, there wasn't any real reason why we didn't go for the certification in the end. We could have, we just felt it wasn't required. And again, it's not even particularly cost restrictive. I think we just got to the end of the project and we were happy that we built a low energy home with the principles, and we didn't feel the need to go on and certify it. Can you answer Penny's question, please? She's just wondering where she can find the conventions for SIP construction, please. I think Pam's trying to unmute with the space bar.
Didn't want to work this morning. It's a bit like me. Okay, so a lot of the values that were mentioned in the presentation were relating to the backstop values to get your notional dwelling. But both Part L for England and Wales and Section 6, the energy section of the Scottish Building Regulations, will give you guidance. So for new build, we're specifically looking at table 6.3 in the Scottish energy section, And in England, we are looking at part L1, which is the dwelling section, new builds, and it's section 4, table 4.1. And that very much is setting out the sort of the minimum performance criteria that you need to achieve before considering any sort of additional renewables. That doesn't mean to say that they're low enough to meet your overall SAP, because obviously you need to make sure that your overall build is going to comply with that and meet your notional. But it's a good starting point to make sure that you don't have a poorly insulated building and yet still a building that passes.
Okay, that's great, thank you. And Pam, another question that's come in just while you're on. Ian Stewart has asked that he'd like to understand how continuity of the airtight membrane is achieved at ground and roof levels. How does the layer on the outside connect to the layer inside? And how does the integrity of the air barrier maintained when fixings penetrate for cladding battens?
Okay. The easiest part of that is in terms of linking external to internal. You don't have to, because Wraptite spans the entirety of the outside panel of your wall. You don't need to link that into an internal vapor control layer, for example. At the ground level, it's just a case of looking at the detail and seeing how you can link it in connection with your DPM or DPC coming through the damp course. It's not too difficult to achieve, depending on obviously the configuration of your wall junction there. And in terms of the roof, again, it depends on the type of roof that you're doing, whether you're switching out a membrane or continuing to use Wraptite. So really, that's the sort of thing that we're more than happy to look at details. If you've got a specific detail that you want us to comment on, we can do that, send it across to us, and we can provide you advice as to how you may go about that. In terms of the fixings, because the Wraptite's unique with that self-adhesive backing on it, there is a degree that when you fix through, that adhesive will help to provide a bit of a seal around that. And that basically means that you're going to reduce the air leakage. It's also the fact that you're sort of locking everything tight together, so you are minimising that leakage. We did some testing down at the UL Wintech lab down in Telford, where we were looking at air tightness and the effects of like windows and bracketry, etc. And actually with the Wraptite and even like a number of brackets fixed on, there was no detrimental effect on the overall air tightness as a result of those brackets. It's things like holes that aren't fixed up or leaky windows that contributed to that more so than fixings.
Okay, thank you, Pam. David, I think an architect question here from Chris. With the SIP system, would you not take on the detailed design stage for a client? Is an architect designer really needed for stage 4, or is it a free design service you provide to work in tandem?
So yes, we would always design to like the SIP system and work in tandem with the SIP supplier, because there's so many different SIP systems out there. So there's different kind of connection details and side details for the different types of system that you use. Having experience in the detailed design section of like low energy homes definitely does help. So if you come to AC Architects, we can definitely help assist and see you right through to site and assist with any kind of thermal junctions. We can do thermal modelling and things as well, and look at specific air tightness junctions that are required depending on the SIP system that you use. And a lot of the Proctor membranes and tapes and things that are available definitely come in useful when we get into that type of detailing.
That's great, thank you very much. So John has asked, John Architect, or John that's an architect, I'm not quite sure which, is it important to ensure that cold bridges are insulated? And this also actually links with one that we've had via email that's just not long come in, who Charles has said, in SIP systems, solid timbers are usually taken around all the external openings. Did you take any special measures to reduce cold bridging there? So between yourself on the first question, maybe David on the second, if we can answer those two, that would be great.
Yeah, of course. It's probably a subject that we've actually spoken about in previous webinars as well. It is really important actually that these areas of cold bridges are addressed. Uninsulated areas such as even your window reveals, for example, will lose a lot of heat regardless of how well insulated your actual walls are. And that's, you know, like the same with structural elements such as steel beams, timber, joists, etc. So yes, it's definitely an important thing to remember when you are actually designing, you know, like a house such as your own.
Okay. And David, did we do anything special around the timber?
Yes, so the timber, although it's included in the calculation in the SAP, because a SIP system comes in at generally, 4 to 7.5% timber content, and a traditional timber kit would have like 3 or 4 cripple lintels at the size of the windows, just depending on the opening size and the lintel that it's supporting over. But generally in a SIP system, you would have 1, potentially 2 timbers at the sides of the windows, so there's a lot less timber to deal with in those areas. And you need the timber there to fix the window back to, but all you do is use an insulated reveal. So you would use a high performance insulation. You could go as far as using the space thermal cold bridging strip, albeit it might be quite expensive to do that at every window aperture, but generally an insulated plasterboard would be enough just to eliminate that bridge and take it back down to reduce that thermal loss.
Okay, thank you very much. Adam, I haven't forgotten about you. You're not getting it easy today. Simon has asked, does the foam within the SIPS panels act as a vapor barrier?
Okay, so if we look at a SIP panel and how it's sort of made up, it's typically sandwiching a rigid foam plastic insulation between 2 structural facings, such as maybe OSB. So when we consider the interstitial condensation, that foam core, being solid and continuous throughout the wall, may act as the vapor control layer or vapor barrier. And therefore eliminating convection and condensation issues that would occur, say, in a cavity wall. But it is important then to look at the membrane on the outside, providing the weather protection to the SIP panels, making sure it's vapor permeable, and allowing those sheathing panels to dry outwards as well. But yes, it can act as a vapor barrier. But also make sure you check on the way the panels are jointed together as well, and get the best detail in there.
Okay. Thank you, Adam. Ben has asked, is the Wraptite factory or site applied? Well, the answer in this particular project, it was site applied. But when it comes to structural panels or modular customers or closed frame timber frame, it can be factory applied, and a lot of our customers do that. And that comes with its own benefits in terms of protecting the panels before and during when they go to site, and then when they're on site. Pam or Sue, anything to add to the Wraptite in terms of how it's applied and where and when?
Happy to answer. Yeah, that's the beauty about Wraptite. There's not one specific place that you can apply it. We're doing a lot in both offsite modular, where it's factory applied, and an on-site, once something's built. So that's one of the key benefits. Obviously, in a factory, and you're going to have much more control over the quality and the install, and you're not going to have the wonderful British weather at your mercy. But yeah, there's no reason why you can't do it either way.
I feel like sorry, go ahead, Adam.
One of the benefits, obviously, when you do apply in a factory, is with it being fully bonded to the substrate, protection during transportation to the site. Obviously, if it's flapping around on the motorway, you're likely to get the membrane damage. So there's a benefit. I
couldn't agree more. I've said this on a previous webinar. Wraptite was in a trial with another membrane that was mechanically fastened, and the modules were actually built in Morocco, and they were then shipped to the southeast coast, the docks there. And when we went to have a look at these modular housing units, they'd obviously been through the elements, and the Wraptite one was pristine. The Proctor logos were there, everything was absolutely protected. And we looked at the other modular unit, which was, again, it was a trial with one of our competitors with a mechanically fastened membrane. And again, nothing against the membrane itself, a very good quality membrane, but due to the transportation and the weather at the port, even with tapes at the joints, it had essentially been kind of ripped off, and there was some moisture ingress and whatnot on these modules. So your point, Adam, about protection, and especially with the storms we've been having, if you look at high rise, you won't see Wraptite flapping in the wind, which is a huge benefit. Probably one we overlooked as a business, actually, but now it's our clients that are coming to tell us just how good that is.
I suppose our development's gone a little bit further now, because these modules are normally made and stored outside. So we've launched Wraptite UV to protect it from UV exposure. In particular modules, while left out in the yard as well. So you've got that reassurance as well.
Perfect. A technical salesman. Excellent, Adam. That's what we like to see. Pam, the questions come in. I feel like you've kind of answered this already regarding punctures, but JW has also said, what about wall ties for external brickwork puncturing the membrane? Have you anything additional to add there?
It's the same principle as before. Again, it depends on the wall ties that you get, but I think most of them would screw into the actual SIPS panel itself. Again, if you do have any sort of punctures that you're concerned about it, then either, you know, add an additional piece of the Wraptite as a tape patch over the top of it, or use our liquid flashing. You know, that's the purpose of the liquid flashing, is for those areas where you just want to add a little bit of robustness. But in most cases, you know, again, it all sort of locks together and it helps reduce any major impact on that.
Okay.
I just add to that, Pamela, as well, that, you know, the fixings with all kind of SIP systems, because the timbers are at 1.2 centres, the engineer usually specifies that everything is screwed back to the face of the SIPs. So having it screwed rather than nailed also gives that additional adhesion and pulls it tight to the membrane. And as you say, you know, the self-adhesive membrane there will self-close and seal around the screw. So it's securely fastened.
Good, thank you. And David, Stuart has asked about the U-value of the roof in terms of the Scottish targets and the U-value of the roof at Tickety-Boo. Do you have any comments on that?
So the targets at the time, I think, was 0.15 for the roof, and we achieved, was it 0.12 on the roof? Yeah. So it's a lot simpler to achieve. Roofs are getting lower and lower and harder to meet, and some of the SIP systems, you know, if they're using EPS rather than PUR, the lambda value of that is maybe at 0.034 or 0.035, so it's a lot higher than what you've got in your system. So some SIP systems might not meet the backstop or the recommended value of 0.15, but some other systems do. And I think a lot of the EPS suppliers now are getting their lambda values down to maybe 0.030 or 0.028. And they're just, you know, they're looking at different manufacturers or suppliers to bring the lambda value of that system down so it inherently meets the backstop.
Okay. And David, another question. Sorry, we're just picking on you today. Shore Developments has asked, on a SIPS build, do you need a breathable cavity between the Wraptite and zinc roof, stone walls, cladding, or render board?
Yes. Basically, it's a SIPS system, but it's still treated as a timber kit. So it needs to breathe and it needs to vent. So you would always have that minimum cavity there. I think the SIPS pocket guide is quite good. If you'd like to use that, you can get that from the STA, the Structural Timber Association. And they have a SIPS pocket guide, which basically talks you through the minimum ventilation gaps externally and internally to maintain the SIPS.
Okay, good. And just coming back, Ben, to one of your comments, I know I answered this before about the application. So I think you said in your experience, it's been that site application needs a lot of management. However, it wasn't using Wraptite. So first of all, we'd be happy to give some to you. I think when I introduced Wraptite to the team here, they'd never seen it before. They'd never even heard of the concept of an external self-adhered breathable membrane, because it is a very unique product. But once our customers start using it, they really enjoy it. The speed of application is fantastic. It's quicker, it's easier. And Adam, can you just explain briefly some of the things we offer our customers in terms of site support?
Yeah, of course. I mean, I think the development of Wraptite caused us to do a lot more work on site because it was a bit new to people being fully self-adhesive. So we started doing toolbox talks prior to install, where we run over basic principles, just make sure everyone's comfortable with a different install concept. We then come back and can do compliance reports where we, you know, walk around site with the contractors, architects, take photos, put a report together that's then looked over by a technical department, comments made if needed, and then sent back and logged for the project as well. But that we don't just do that for Wraptite, but it's more common with Wraptite because it's a different concept to install. I think we've now launched our application as well. So if you can't wait for a rep to come out to site, we can have photos taken, sent over to us on an app, and technical will respond as soon as possible, really, to speed up the process. But yeah.
And so many fantastic questions, guys. And as I say, we will just keep answering these, and there's more coming on email as well. So please bear with me. I'll come to Sue because I've not spoken to you for a while. This is from John via email. When considering air tightness, is offsite manufacturing always the better option?
Okay, for air tightness, it can be. And a lot of that is obviously what we've sort of like just discussed earlier. The process of manufacturing off-site means that there's obviously production controls in place to deal with like the detailing aspects. The panels also tend to be standardized. So with that high level of production control, because of the factory environment, then you get a very consistent application of the membrane. Not to say though that on-site manufacturing can't achieve the same levels of air tightness. Obviously, a lot of that will be down to the actual workmanship on site. And there's different things to contend with, obviously, like when sort of like considering on-site installation, things like weather, storage, again, like what Adam said as well, sort of like where do you store the material, the panels, etc. So there's pluses for both.
Thank you, Sue. Desi, your question around the DER of Tikitibu, it is 6. So in comparison to the target, which is 17, right, guys, in terms of CO2, kilograms of CO2? I'm looking for nods, but yeah, so the DER is 6. If I can come back to, sorry, go ahead.
Sorry, Keira, I was just going to answer that. Yeah. The dwelling emission rate is based a lot on the design, the orientation, solar gain and position within the UK. So the dwelling emission rate usually varies depending on the design, especially when you're working in self-build. If you're doing modular houses, then you would have a target for maybe each house type. But for self-build like your project, the dwelling emission rate comes from from the figures that they put in based on the backstops. That gives you your target emission rate, and then your dwelling emission rate must exceed that target emission rate or be a betterment on it for it to then pass the SAM.
Thank you, David. And could you answer Stuart's question as well, please? So what was the air seal strategy and projected window frames and openings with Wraptite, EDPM tapes, etc.?
So it all comes down to the window sealing method. So the Wraptite is usually cut and returned into the reveals. Then the window is installed with its 10 mil tolerance. With it being a modern method construction, that tolerance can be, reduced. Some SIPS companies, or window manufacturers will take that tolerance down to 5. And because it's going to be manufactured in a controlled environment, you can order your windows and doors at the same time as your kit, which reduces the site time, gets you wind and weather tight a lot quicker on site. And then the products that you use to seal around the windows is what would give you your air tightness. We usually recommend like a compressible foam sealing tape, which is a tape that expands and moves with the kit. And that would give you a complete weather tight and airtight seal. Then that's backfilled with an expanding foam. And then you use an internal air tightness tape just to seal the junction between the window frame and the kit itself.
Thank you, David. That's great. Simon has asked, lovely house Keira, did you put security in at the time of construction? So we did have a sort of strategy for security after we realized what we were building. So, I mean, just in terms of security around the house, we have 6-foot fencing and a commercial grade, aesthetically pleasing gate. So the garden was kind of designed initially for my Labrador, who's since passed away, I'm afraid, but it's completely enclosed, which is one part of your security. And he's been replaced by the cats. He would be rolling in his doggy grave up there. Shame. And we also put in, multifunctional cameras. So I think there's 16 around the house and the driveway. We now have internal cameras for some of the baby rooms, etc. And, the usual things like, app controlled cameras, door apps, etc. So yeah, it's a bit like Fort Knox. I could never sneak out and have an affair. We've got every angle covered, which is good because I think it is good to certainly have eyes on your home when you're remote in the countryside like we are. More questions, fantastic. Charles has asked, do we have standard fire barrier details to protect cavities required for ventilation? I'm looking at Sam and Sue here.
Yeah, it's in terms of the fire barriers, there is quite a bit of guidance in like the individual standards as to where they should be it around doors, windows, changes of levels in between. We ourselves don't have specific details because we don't supply the actual cavity barriers. So I would suggest that you would really need to speak to the people that are going to supply your barriers, because it might vary depending on whether you've got one that obviously completely fills your cavity, in which case you'll need to provide ventilation slots above and beyond and below it. But if you've got maybe an intumescent one that actually allows that ventilation to pass up, and then obviously if there is a fire, it swells and closes off the cavity, the detailing will be slightly different depending. But usually in terms of the Wraptite side of things, it would line your SIPs or your sheathing board behind that barrier, and that would be fixed over the face of the Wraptite.
I just add to that, all of our designs, we have the ventilated fire barriers, because with a SIP system, although you've got the traditional stone on your project here, with the timber cladding, it's traditionally hung from the SIPs panel itself. So you can get a lightweight finish system onto the SIPs without, you're reducing that foundation, any transfer of load down, because the SIPs panel can take the finish itself. And then you don't want to, introduce ventilation at intermediate flow level. So we would always have horizontal fire barriers as intumescent fire barriers, and the vertical fire barriers is at least like 38mm thick timber to give you a half-hour fire protection, unless there's a requirement for more. The vented fire barriers, we've had this quite recently with some suppliers. You need to check with them and make sure that they will allow the installation of it on a SIPs panel, with all the fire regulations that are going around just now and everything from the result of Grenfell. Building control and companies like that, like private building control companies in England as well, are being a lot more vigilant about what they do and don't allow on a SIP system. So I would always check with your SIPs manufacturer what ventilated fire barrier is suited for their system.
Okay, thank you, David. Adam, Josh has asked, can you offer any advice on how to address moisture ingress within offsite panelized systems? Muted.
I suppose Wraptite, a fully self-adhesive, vapor permeable external air barrier, could be your answer, especially for simplifying the details. I think, as David mentioned earlier, for the joints of the panels, the windows and door openings. We also have the Wraptite liquid flashing for any surface penetrations. That will provide a durable air and vapor and moisture seal for the lifetime of the wall as well. So it's all about addressing those little details, and we have solutions for that, really.
Good, thank you, Adam. So Frank has asked, once we've applied Wraptite to any kit, be it SIPs or traditional, how long can the Wraptite be exposed to weather before roofing or cladding is fitted?
As a general rule of thumb with the Wraptite, in obviously UK climate, we say 120 days. So it can be left exposed for that length of time without sort of like any of the properties of the membrane being affected. We have done some research ourselves into longer term exposure, and in certain situations, maybe the membrane has been left exposed longer than intended, but generally you find that the properties of the material, the MVTR, the moisture vapor transmission rate, the air tightness, etc., does not get affected.
Good, and obviously, as Adam's mentioned earlier, having the UV version of the Wraptite, which is a fairly new addition, so we've been working on that for a number of years, so UV stable equivalent.
Yeah, that one can actually be left exposed for up to 12 months, long-term exposure.
Good, thank you very much. Okay, so questions are still coming thick and fast, which is fantastic. On a SIPs roof, do you need a vapor barrier on the inside ceiling if the roof panel has Wraptite, ventilated cavity and zinc, or Wraptite cavity with a sedum roof?
Again, what we would do there is the requirement for a vapor barrier really depends on the whole construction. So what we would do there is we would look at that construction, do a condensation risk analysis. Again, it depends on what the building's actually being used for, etc. What the like if it's like high risk, low risk, etc. We would take all that into consideration and see whether it is or not required. As was mentioned earlier, obviously, like the SIPS panels themselves, because of the structure of the material, like of the panels, they generally tend to be quite vapor tight anyway. So, but we would look at that, and if he needs one done, then he can send in the details and we can get that done for him.
Okay, fantastic. David, if I can come back to you, please. This is again another architect question. Julie has asked, is it important that your architect understands let me start again. Is it important that your architect understands the benefits of modern methods of construction?
The short answer would be yes. I mean, modern methods of construction like SIPs, ICF, and closed panel timber systems, they each have their own benefits. There are inherently low levels of air tightness, high thermal efficiency, off-site manufacturing, and reduced site time. Understanding how the system works allows the design of the build to be driven by the construction method. It also comes down to site tolerances, understanding the site tolerances and the standard construction panel sizes and air tightness levels achievable and making sure it's prepared in advance as you can be. At AC Architects, we've been designing the fabric with fabric first principles since 2009. We're utilising the benefits of modern methods of construction to design low energy homes that not only look great, but they actually work efficiently and can be built. And out of many of the projects we have worked on across the UK, we see all of our projects through detailed design and on-site information. And if your builder isn't familiar with any of these modern methods of construction, we offer toolbox talks on site as well, so we can come on board and educate your contractor and kind of walk them around site and talk them through the detail as well.
I second that. They do that. Very proactive during our build, certainly. Frank has asked, with respect to the higher wind speeds we're experiencing, how does this affect the integrity of the adhesion of Wraptite to the structure? Now, I touched lightly on this earlier, and I mean, if anything, having it self-adhered to the structure is a benefit. How about the integrity of the glue? I'm trying to think how to describe it, how we can reassure people. Pam, is that something that you can go into, the performance of it on the wall once it's up?
Yeah. Certainly, Wraptite's been around for a number of years and has been used in some quite challenging environments and at high above ground situations. So I mean, like the storms that we've been experiencing hasn't been the first one. And I think what we need to remember is that the adhesive, although it's quite tacky when it first gets applied, what we're actually doing is we're rollering it. You must get a good bond and you roller it onto the surface. That adhesive also cures, so the actual initial bond is not what the final bond is. As long as to be fair, if anything, in terms of damage, is if you've not sealed it properly, you could get the membrane delaminating and the adhesive remains in place. I mean, once that's bonded and that's cured, it's really difficult to get that adhesive to come off something like a plywood or a sheathing board. So really, because everything is locked together, I think that's the best way to describe it. You're locking it together. There's no pathways for air to get behind it and billow up. There's no way it can get in through joints or poorly applied tape. It's solid once it's there, and it's unlikely to have any, unless I think your whole panel would go before the actual Wraptite would start coming off.
Adam?
I was just going to add, I've actually been on a high-rise site in Manchester on a very windy, bad weather day. The flag was almost blowing off on the bottom ground, and we're all the way up, I think about 18 meters, 20 meters high, and the membrane wasn't even moving, bonded onto the substrate, and it was just, not even budging. So,
yeah, absolutely. I mean, I think it's important to remember this isn't a taped, this isn't a membrane that's sort of taped or intermittently with adhesive. This is 100% full coverage adhesive. So once it's stuck down, there's not air pockets that it can get into, presuming it's stuck down well and as per our instructions. And I mean, Wraptite was born for the US market. We introduced it to the UK six years ago, but it's been in the US for 10, 12 years now. And it's used all over the country, including Alaska, the Windy City, Chicago. So it has a lot of history in high rise, and it's a very durable and good product.
One of the things I do on site is when showing contractors is we get a small sample, peel half it off, bond half it onto the substrate, leave it for a bit, then come back to it and get the contractors to try pulling the other half off, and you really feel the poor adhesion there, struggling to get it off, showing its magic, if you like.
No chance. Yeah, when we built this house, actually, during the construction, we filled all the window gaps before the windows arrived with Wraptite. And like that, you know, someone would stick something to a bit of paper, or we'll just pop that there for now and have a look. Oh, and of course, it rips complete plans. Someone tried to put the plans up on one at one point, and they had to be replaced. You know, nothing comes off it. But one of the other benefits was that the builders, when they were doing the construction, said, you know, this is one of the warmest builds we've ever worked in, because it was so airtight, and they weren't getting any airflow coming in, the cold air coming in during the winter. It was a really nice, cozy environment because the house was completely wrapped up. So another benefit that kind of saw the course through the construction period. Sue, can I come to you, please? Because we have them by email and I forgot to ask it earlier. Sorry, it was actually before the webinar. Another one from Ian Stewart. Is the membrane suitable for running over the roof continuously from the wall sandwich, particularly say where a fibre cement cladding is brought up from walls over the roof to achieve a continuous visual effect? Or do you recommend using a different membrane for the roof connected to the Wraptite?
No, the Wraptite can be used. A lot will depend on the actual, you know, design, the join between the, you know, like your roof and your wall panel. But in theory, you know, the Wraptite can be kept continuous up your wall, up your you know, like your roof construction, and then your external cladding applied over that. So yeah, in principle, there's, you know, there shouldn't be an issue there. No need to use a separate membrane.
Okay, that's great. David Charles has asked, are the new requirements expected for minimizing embodied carbon in construction likely to affect SIPs and Wraptite solutions?
Is this the future home values that are considering?
I guess so. Charles, do you want to, if you have any clarification you can provide on that question? Maybe we'll see if he puts any more detail to it and come back to it.
Okay.
Okay. Frank has also asked, would you recommend the roofing cladding is fitted as soon as possible after the Wraptite is fitted, rather than leaving it for 120 days? So I think you answered this one before. You're on mute, sorry.
There we go. Yeah, I mean, like, obviously good practice would be to, you know, like, sort of like install your cladding as soon as you know, like, as reasonably possible, you know, like, rather than leaving everything to the last minute. But yeah, so cover it as soon as you possibly can. But as I said, the Wraptite can be left exposed. We're happy with the Wraptite being exposed for 120 days.
Yeah, I think we would say that about any of our membranes. You know,
exactly.
As soon as possible, cover it up. I think any manufacturer would say that. But that said, we had projects where people were coming to us after lockdown saying, we've left Reflect Shield exposed for a year. What do we do?
Exactly.
We would support by going and looking and helping with that. But yeah, it's good practice to try and cover it as quickly as you can. Another one I had in via email here. Just bear with me. Let me find it. I presume Wraptite, if I can go to you, Pam, for this one, I presume Wraptite can only be used on buildings up to 11 metres due to fire regulations. Anything above this would be better to have your ProCheck A2 product. So Pam, perhaps you can explain the difference between ProCheck A2 and Wraptite, and then obviously go into the details of the Class B and the 5.
Absolutely, it's really important to understand those differences. So Wraptite is a vapour permeable airtight product. So that means that vapour will still be able to pass out, allow your building to dry out, and any sort of moisture that drives from the inside to the outside can pass through that. It's not going to stop it. The ProCheck A2 is a A2 product, but that's a vapor control layer. So that would be used always on the inside line, on the warm side of the insulation, to actually physically stop any extraneous vapor getting into the wall in the first place. Probably a good time to bring in another new product range that we brought in, the Pro Breathe A2 membranes, where we've now got a fire resistant class A2 breather membrane, an airtight one and an air permeable one. So they can be used, but we've also got to temper with the fact that Wraptite is class B free hanging by itself, and also class B on things like calcium silicate or cement particle board. Now, most timber probably isn't going to be going up towards 11 meters and beyond, just because the sort of the limiting use of it. But we've also got to remember that there are some parts of the construction that have exemptions for the performance. Now, in Scotland, the membrane is one of them, so they don't put on that it must be an A2 membrane. So you can still use Wraptite, no problem at all, over 11 meters. In England, the requirement is over obviously 18 meters, and they do put the added stipulation that it must be a class B. So again, you know, depending on the substrate, it still allows Wraptite's use. So it's really a case of trying to look at what your whole strategy is and deciding which is the best membrane for you, but don't be disheartened. Just because it gets over 11 or 18 meters does not preclude the benefits of Wraptite.
Thank you, Pam. One for me here, Marina Phillips has asked, for me, anything you would have done differently or regret? I love our sunken living area and our sunken bath, but now we have a 9-month-old. All he wants to do is try and climb up the little stairs. And there's a lot of pokey bits and sharp bits, which we've had to cover, etc. And trying to give him a bath in the only bath in the house, which is sunken, is just killing my back. But no, I mean, realistically, you design a lot of things for visual effect and how you picture your life at that point. So I probably would have maybe just given a little bit more thought to some of the quirky things. And of course, but we still love those areas, but realistically, sometimes the functionality is not quite what we would have liked, and otherwise not really. I mean, we're very happy with the design. Maybe doing the garden design at the same time, but that's always an afterthought. So you kind of live in a bit of mud for a few years while the grass develops, but we are now thinking about what we want our garden to look like, and then the thought of having diggers and things in again, and we were just like, oh no. So maybe a plan alongside the house, but to be honest, we're really happy with the design and how the whole construction process went and how it all came about. So not really. Okay, we still have quite a number of questions. I'd say 4 or 5 left. So please ask away now if you can. I have quite a few still to go through via email and Twitter, and then a few more coming through on the YouTube feed. So Pam, if I can come back to you, what airtightness values can be achieved by purely good design, i.e. following accredited details?
Yeah, I mean, I think a lot of people automatically assume that the only way to get good airtightness is by using membranes, but it's down to workmanship, it's down to detailing, it's down to the quality of the install and making sure you don't have the proverbial square hole for a round pipe, or if you do have that, then you fill it in and you seal it. Looking at sort of a standard timber frame built well, that should easily achieve sort of like an airtightness of 5, with a little bit extra care and installation of, you know, an airtight membrane or a vapor control layer inside, which we know is harder to detail around things like, you know, wall junctions and joist junctions, etc. You should be able to get down to potentially 3. With things like an external barrier like Wraptite, so simple to get down to sub 3 and even sub 1, you know, even on some of the most complicated buildings, because to bring out my analogy that I like to use is it's easier to wrap a box full of presents than individually oddly shaped parcels. So it can certainly be done, and that's backed up by the Scottish, certainly in the Scottish energy section 6, where they do say that they reckon that, you know, around 5 is more than possible using the accredited details published by the Scottish Government.
Thank you very much, Pam.
I just add to that as well, like all the advice Pamela give is really good. But just to add to that, you know, all of our designs that we do, we design to an air tightness of 3 or less so that we can get a mechanical ventilation with heat recovery system in. Anything above 3 in your mechanical ventilation with heat recovery just doesn't work as efficiently. So following accredited details alone to try and get to the kind of standards that you've built to Keira just probably wouldn't cut it. You need to, you know, understand the types of membranes and tapes that, you know, Proctor supply, where to apply them, how to apply them, and when they also get installed in the stage in the build as well, to make sure that, you know, they're not penetrated in future by services or anything. And that's kind of the level that we design to at AC Architects all of the time, and generally aim for around an air tightness of 2.
Good. And do you generally, your builds will generally achieve that, David? When you're designing to a certain, do you experience a lot where you have some problems, or do most of them generally achieve the air tightness that you design to?
Most of them do achieve it. You know, we always recommend to get a pre-test done. So before you put your plasterboard in, once your windows and doors, your tapes and everything done, get a pre-test done at that point, and your tester, your air tightness tester, can go around with a smoke gun, and you would clearly see where there's any weak points, you know, where smoke's being drawn out through the building. And that gives you another opportunity to go around and tape any weak junctions. I mean, the Wraptite certainly helps that because it's all in the external face. But when it comes to internal junctions, like where the SIPS meets the floor, or where the windows are in the apertures, or even a weak point where the roof cantilevers out over the structure, if the Wraptite's not continuing round on the outside there, you would want additional air tightness tapes at those weak junctions. And that's what we can come out and do our toolbox talks for, to basically talk your contractors, or if you're a self-builder, through all the areas and weak points that we feel you should be taping. And then at that point, when the pre-test is done, it will tell you it might come in slightly above 2, and then you know there's a bit more taping to be done. And then once the plasterboard finishes in and that's skimmed, that is giving you another inherently kind of airtight layer as well. So you do generally get down to 2 or less.
Thank you very much. Adam, did you have anything to add there? So you're off mute.
I couldn't resist. We have had projects where they've achieved extremely low rates. So St. Sidor's Point, which has used Wraptite, Fire Shield, and a number of other products within that build to achieve its low air changes and air tightness. I think it achieved in its final test, it achieved an air permeability of 0.3 meters cubed an hour per meter squared at 50 pascals, which I believe equates to an air tightness of 0.1 air changes per hour at 50 pascals, which is very, very low. And Wraptite was a big part of that design in achieving that. So yeah, thought I'd mention it.
Yeah, I was going to say as well, really going back to what David said, but in the early days when we were bringing Wraptite in, we did a comparison on a site where it was a semi-detached house. One half was done with Wraptite, one half was done with traditional breather membrane, vapor control layer, and insulated timber stud. That wall came in just below 2. I think it came about 1.87. So they spent an hour with the smoke sticks trying to seal everything up. They went next door, tested the Wraptite one straight in at 0.87. They went back, retested the first one. They still could only get it to 0.99. So that was with one product, nothing else in that frame, bar Wraptite.
Yeah, all the Wraptite products do certainly help, and you've got the Wraptite floor zone as well, so it's right round the perimeter of the floor junction if you need it. And then the external Wraptite itself, it's always going to bring you down a lot lower than vapor control layers alone.
One thing, I was on a site yesterday looking at a VCL install where it was the primary airtight line, and you've got problems like sticking onto the concrete, which can be very dusty. Then when it's installed, you've got follow-on trades come in and kicking up the laps because, again, it's just a bit of membrane for them. And it just made so much sense moving the airtight line externally for that kind of design as well.
Good. Charles has asked, in fact, I'll go to shore developments first, sorry. Do you need a wall cavity radon barrier if the SIPS building has been covered in Wraptite? Radon is an issue in Jersey. Sue?
If you have gas on site, regardless of whether it's radon, methane, carbon dioxide, then yes, you should always have a solution for the, for that gas in the first place, regardless of whether you're doing a SIPS panel, traditional masonry build, etc. So we do have our Radon 400, which is our new membrane, which would be applied obviously over the the footprint of the building, with the starter band going through the cavity to seal off that cavity from any gas that's able to sort of like into the building that way. So yes, you should always deal with your gas first.
Okay, thank you, Sue. So we're coming to the last couple of questions now. Pam, tongue-tied today. Can waste adhesive membranes be recycled? Can timber panels be recycled after membranes are fully adhered? Oh, you're on mute, Pam, sorry.
Apologies. Yeah, it's a really good question. It's actually one that we ourselves are aware of and thinking of. I suppose it's one of the downsides to the adhesive being so good. You can't just sort of like whip it off like a post-it note and move it. In theory, yes. I mean, the majority of the membrane is polypropylene, which can be recycled. One of the biggest problems now is we don't necessarily have the infrastructure to be able to adequately separate these products and recycle them. Although we don't envisage any of these projects needing to be replaced for 50, 60 years. We're not looking at sort of single-use plastics here. But certainly as a company, we're fully invested in ways to look at how that can be facilitated. I know that there's some people that we're speaking to are talking about, is it possible to use like a panel once it's removed, sell it on almost like a gum tree for building panels, because they may still have a lot of functional life left in them, but what they were initially designed for, the need's not there. So yes, it is potentially possible if the infrastructure is there, but I think we also have a long way to go in improving the infrastructure to allow us to recycle more materials.
Okay, thank you, Pam. Charles, Wraptite is expensive. Okay, to reduce wastage, I have the sheet pre-cut to suit unusual shapes and openings. Whilst this is not mentioned on your literature, would you recommend this even if it reduces sales? I mean, certainly it's not something that Proctor could offer to do for our customers. Unfortunately, we're not geared up to fabricate the membranes we manufacture en masse. So we're selling millions and millions of square meters of these type of products per annum. We just don't have that set up. If our customers want to, I mean, a lot of the Wraptite sales are off-site in factories, so big sheet application, same with the high-rise facade. But absolutely, I mean, if there's a new build customer who, wants to try and utilize that role in a more efficient way that they see fit and chop it and do what they like, then, we would say, go ahead and do it. And I think, like yourself, Charles, most people will use their initiative and perhaps use their, the roll or two that they're buying for their new build and do that, hopefully. So we wouldn't mention it because we wouldn't want people to come to us and ask us to do that. But I think it's a good point. And certainly, even if it helps with the detailing, we do things, Pam, like preformed corners.
Yeah,
probably worth a mention at this point.
Yeah, absolutely. I mean, we don't mention it, but it's implied within the installation that, you cut it. It's very much about thinking about the sequence of install and where you can cut it down and best fit it. So we have the window corners, you do the windows. So we wouldn't normally expect to see an application in a traditional way. And like yourself, I mean, you had a reason to put it over your windows, which was to keep the building wind and watertight. In most situations, we're not seeing that. We're seeing people dressing it around the windows and doing the main sheet or, that way you can really reduce the waste. On one of our new products, the Pro Breathe, myself and James, our head of facades, did an install last week, a trial install with a corner unit, and we pretty much had maybe A4, A3, between an A4 and A3 area of material left over from a rig that was probably about 2.4 high by about 6 meters long. So, you know, with a bit of careful thought, a careful planning, you can minimize your waste hugely.
Good, thank you, Pam.
Just to add to that as well, we get this quite a lot with the Wraptite and the cost. You know, we always say to our clients, fabric first approach is investing in your fabric foremost. You know, so pay that money up front. Seeing the airtightness levels like we discussed earlier, you know, between a vapor control layer alone and Wraptite, see the difference between 2 and 3 airtightness level down to, you know, 0.64 like on yours, Keira. That's the life of the building that airtightness remains for. So the reduction in your bills over the course of the building is far going to outweigh the cost that you have at the outset for the Wraptite in the first place. So always invest in the fabric first.
And to add on to that, Wraptite can be cost effective for your projects. It can make cost savings in certain areas, speed up labour time, for example. It varies from project to project, whether it's modular build, off-site. So if you get us involved from an early design stage, we can go, well, actually, you can save money here and here by using Wraptite because of X, Y, Z. So yeah, there's more to it than just being a breather membrane.
Yeah, absolutely. Thank you, Adam. David, I'll come to you for our last question, if that's okay. I'm not seeing any more coming through. Do all architects, Paul has asked, do all architects know how to detail a low energy fabric first home?
I think all architects understand, or at least should understand, the principles of low energy and fabric first, but knowing how to design and detail a fabric first home and then deliver that to site is completely different. You know, at AC Architects, we consider all low energy factors from first site visit, you know, and site orientation. You have to think about so much when designing and implementing low energy homes. Things like the orientation to maximize solar gain, like overshading from surrounding trees or buildings, having all your habitable rooms to the south elevation or the most south facing elevation, and wet rooms to the north, so you're maximizing that solar gain to the habitable rooms. Then finer things like membranes, vapor control layers, all of these products that Proctor specify, that, you know, knowing where to put them and how to use them definitely helps. And things like thermal junctions in the kit where heat is more likely to be lost and requires some attention, you know, having all that knowledge from your architect and as far in advance of the design process as you can certainly helps, you know, get to the levels that you want to achieve.
Thank you. Thank you very much, David. Okay, well, that brings us to the end of our Q&A. If I've missed any, and I probably have a couple, so I really apologise, then we will reply to you via email in due course. So thank you very much. David, also, just while you're here, thank you for your support on building the house, and AC Architects and Allan for all his help as well. I think it was a great project, and I apologise in front of everyone else here for hassling you, I'm sure, over the number of months when we were doing the project, in a nice way, hopefully.
Yeah, no problem. It was a pleasure to work on the project, and it's good to see it through and finished, and to have the levels of energy performance, you know, far exceeding what everyone expected, really. Good.
Okay, so again, a little bit of an apology for people's talking on mute there. I really quite like that, because it means that we're all using Zoom a little bit less. So we got it down to a T where no one was forgetting to unmute. So I really actually think, you know, it's quite nice, because we're now seeing each other in person a little bit more, thank goodness, coming out of this pandemic. And that's why we've reduced our webinars to one a month. We are conscious our audience, a lot of people catch up after the webinar, but, you know, time is quite critical now, and I know the industry is very, very busy. So our next webinar won't be for another 30 days or thereabouts. So please diary it now. It's the Friday the 25th of March, and the topic is Enerfit Fabric First in Retrofit Construction. And we have a very special guest, Katrina Jordan, who is the head of retrofit programs at the Construction Scotland Innovation Centre. And a little bit more about Katrina. She's worked on a range of funded projects such as Inclusive Value, Offsite Ready, and Embracing Modular Innovation in Construction. Her real passion is in low carbon programs, including the training and upskilling in passive house, Enerfit and retrofit. So a wealth of experience there that she'll be able to share with us next month. Again, please go to our webinar page. You'll find everything there you need in terms of how to have a chat with one of our technical team or sales team. You can download your personalised CPD certification at the same link. You can download material information, go into our online web chat and have a chat with one of the team. So essentially, you'll find everything you need at www.proctorgroup.com/webinar. You will receive a follow-up email to this, which has a link to the replay. As I always say, please feel free to circulate that. There will also be a link to a short survey. So if you have time, please fill it out. We do read every one of them. I read every one, and we really take on board the feedback, and we use that to shape future webinars and how we could be doing things better. It really helps us out if you give this video a thumbs up, and please subscribe to our channel. That will keep you up to date about any other YouTube activity that we're doing that isn't necessarily a webinar. So we have new things coming out all the time. It could be product launches, it could be training, it could be toolbox talks, our REBA accredited CPD seminars, etc. So please keep an eye on our YouTube for all that information. So I think that's it. Thank you very much. Thank you for watching this webinar, and as I say, I hope you enjoyed learning a little bit more about Tickety Boo, and we will see you in 1 month's time. Have a nice weekend.